Hello everyone, welcome to the channel of Developers and Coders Club and NIT-A. Here we will be discussing the problem del operation of status 105. So in the problem you have to help the chef to find some pairs. So let's read out the problem first. So in this problem the chef is in a somber mood. So he has an odd integer m and he has to decode it. So basically, has to find out a pair of integer x and y such that this condition is satisfied. The condition is this thing is the bitwise or between x and y, and then this one is bitwise or bitwise or between x and y. Then you have to take the product of this two, and if this is equal to m, then your x and y are the pair that we need. So you have to find out any such pair and that will be the answer. So let's see the input format. So input format is easy. T is the number of test cases and then every test case will contain a single or integer and you have to output just two integers that will be x and y and that will be your answer. So let's look at your sample input output. So here 4, 1, 49, 21, 35. These are your inputs. So for 1, the output is 1, 0. So you can see if we take the OR between 1 and 0, the result will be 1. And the XOR between 1 and 0 will be also 1. Product between 1 and 1 will be 1. Here for 3, 4, you can see that their bitwise OR is 7, bitwise OR is 7, and the product is 49. For third one, you can see that their OR is 7 and their XOR is 3 and product will be 21 and then this one. But do we need to actually use this method because this one doesn't have any sequence or something by which you can find out the solution. So basically you have to go for your intuition and think what can be the answer. So basically, if you know this operations bitwise OR and XOR, then you know that if just that this 5 is given to you, then it in bit form will be 101. Now just suppose and we take a number, random number. This don't consider this part. Just take it a random number 4. Okay. So 100 is the number. So what will be the bitwise OR between 5 and 4? So here for 1 1 it will be 1, for 0 0 it will be 0, and for 1 0 it will be 1. Basically in bitwise OR we just compare the bits, and if the both bits are 0 then we will output 0, otherwise we will outputting 1. So you can see if you do it between 5 and 4 you will get simply 5. So actually, if you focus, then you can see for every odd integer, if for every odd integer, then wait, I write it in new page. It will be better for you. So basically, odd integer and XOR between odd integer and odd integer minus 1 will be always equal to odd integer. How is it coming? Let's see. So basically, you can take any odd integer. So what happens between that? What happens in that is wait. So for every odd integer, you can see that this one is 1. So this one will be always activated for odd one. So for just odd minus 1, you have to remove this bit and make it 0 and you will get the same bit, same ditto same for this. So if you eh, for any odd integer, if you take OR, then you will get the same 101. It we can see it for other integers too. For example, 15. So what will be its bit form? 1111. Now you just subtract 1 in it and get 14. Okay. So we see here for 14 you are just deactivating its last bit and you are getting same thing. So you take the OR of this and you will get 15. How? Wait, I show for this one too, this one. So how will it happen actually? So here for first one, you can see both are one. So one. For second one, again one. Third one, one. Fourth one, one. You can see you are getting this 15. You can do it for any odd integer and you will always get same result. Now we go for XOR. So if you take XOR of 15 and 14, you can see that here. Wait, I show you this one too. So here is your XOR. So for XOR, if the both are same, then your result will be 0. So here you can see 1, 1, it's same. So you get 0. Then here 1, 1 again same, you get 0. Then third one also 1, 1 same, 0. But for last one, you can see this one is never gonna be same because for odd one, it is last bit activated, but odd minus one is always even, so last will be deactivated. So they will never match. So if they won't match, then sort of the two will be one. So you can see this value here we get just what will be value of this one, this door. This is one, okay, and this one is 15. So what is the product of 15 and 1? It is 15, your number. Same, you can see here for this one too. First one, here for 5. This is 101, 4, 100. The bitwise XOR between them will be 5. And what will be the bitwise XOR between them? So see, here 1, 1 is same. So 0, 0, 0 same. 0, 1, 0 different. 1. Here this is 5, this is 1. The product between 2 is 5. So similarly for every odd integer, you can just check. You don't have to check actually. It you can just make the common logic that the if for every or wait for every odd integer, this one. For every odd integer, the bitwise OR between the odd integer and odd integer minus 1 is the odd integer same. And here let me write one more thing. So odd integer and XOR. We use this symbol for XOR. So odd integer minus 1 is equal to 1. So now you can see the product of these two will be the odd integer. So you can take these two numbers, right? The odd integer and odd integer minus 1. So implementation part is of this is very simple. Simply you have to input this number of test cases. Then in number of test case, simple you input the number n, and then you have just output the number n and n minus 1, because that's what we found out with our intuition here. So this will be your solution. You can check it. Okay, you can see this one is correct here. So this will be your solution for the question. Very easy question. Just you have to know the operations bitwise OR, bitwise OR, and a little bit of intuition, or you can use you can make test cases by yourself and run it, and you can find out how it is working. So thank you for watching.